All right, so again, we are in lesson 11 in module 5, and we're still working on volume of cylinder, or I'm sorry, not volume of cylinders, volume of cones, okay? And I'm going to write the formula up here that we've been using. Volume equals 1/3 times the area of our base, which in this case is a circle, so times pi times our radius squared, and then times the height, which is the distance between, for a cone, the circle and the vertex, the point of the cone. Okay. All right. So the volume of several cylinders is shown below. They're not around a scale. Okay. So don't get hung up that they all look the same and these numbers are different. It says use the dimensions of the table below to find the volume of each cone. Then under the cylinder column, record the letter of the cylinder above that could have been the same height and same as radius of the cone. All right. So here's what we're going to do. Okay. I'm going to use this formula up here. Okay. So I'm still using formula. I know I told you to write a formula. I'm still using it. I'm just not writing it 3 times. Okay. Kind of jump here to filling it in. So 1/3 times pi times our radius. Now our radius, it just tells us right here is 8. So 8 squared, see how I'm just filling this in here, times our height, times 2. So then calculator. Oops, not what I wanted. Kind of move it over. I know you won't be able to see everything I'm typing in, but you'll at least be able to see what I'm doing. So 8 squared times 2, then times pi, and then again I'm going to divide it by 3. Okay, and I'm going to get, it's approximately equal to 134, I'm going to say. And, well, it looks like they're using units for units here. Not going to worry about it. Okay. All right, so now let's do this next one. I'm going to do all 3. Okay. I guess I should put units so we know what's the answer. Cubic units. Okay. So I'm going to do the same thing here using this formula. 1/3 times pi times our radius. Well, if our diameter is 6, our radius is half of that. So our radius is half of 6, which is 3. So times 3 squared times our height, which is 4. And again, you can kind of see what I'm doing here, right? I'm going to go 3 squared times 4, our height. Again, we can multiply in any order, times pi. And you can multiply it by 1/3 or remember, divide by 3. Same thing. And I get about 37.7, we'll say. And those, again, since it's volume, are cubic units. All right, one more. Okay, so volume equals 1/3 times pi times our radius squared. Our radius is 2.5 times our height, which is 2. Grab the calculator. And you can do it the form. You can say pi times 2.5 squared times, not what I meant to do. Maybe I can't do it that way. All right. Sorry. Just easier for me to do it like this on this calculator. Times 2 times pi times 1/3 or divided by 3. And we get approximately equal, let's say 13.1. Okay, now that we found our volume for each of the cones using our volume formula, now we want to see the relationship between a cone and a cylinder. Okay, so remember, our formula for a cone is really similar to formula for a cylinder. All we do is we divide by 3 or multiply by 1/3. So how do we undo dividing by 3? We multiply by 3. So what we can do is we can take our 134 here and multiply it by 3. And we get 402. So remember, we rounded this right here. So if I look at these, which one is closest to 402? C. Okay. Now, let's do the same thing here, because again, that relationship. A cone's volume is a third of a cylinder's. So I can take 37.7 and multiply it by 3, and we get 113.1. And if you look at these, which one is closest? Now again, there's a rounding error, and there's the fact that they probably use 3.14, and I'm using the pi key. But this is really close to E right here, right? All right, and then finally, I'm going to take 13.1, the volume of my cone, multiply it by 3. Not that. Try this again. 13.1 times 3, and clear everything out. 39.3, which I should have known. Sorry. So if I look up here, ooh, 39.25, that seems to work for me. So that's B. All right. So this problem, all it wanted to do is really focus on the relationship between the formula for volume of a cylinder and volume of a cone. Okay? A couple examples and we will be done. The cone below has a diameter of 12 units and a slant height. Slant height. This is a new one. Slant height of 10 units. This is slant height. Okay? Now, if we know its diameter here, the whole thing is 12, I know that its radius is 6. So now we don't know this up and down height. Okay? But it's a right triangle. Okay, and if I redraw it right here, this is a right triangle, and a right triangle, I can find a missing side length using the Pythagorean theorem. So I'm not going to sum up today's lesson. I'm going to use my Pythagorean theorem. Okay? So 10 is my C, because it's across from the right angle. So I'm going to say a squared plus 6 squared is equal to 10 squared. So a lot of the stuff doesn't go away that we learned, guys. A squared plus 36 is equal to 100, 10 times 10. Subtract 36 from each side. And we're left with a squared equals, for the sake of time, I'm just going to use this calculator, 100 minus 36, which is 64. Here's good review for your test corrections you can be working on. We take the square root of each side, and we get a equals 8. So, now with our formula, volume equals 1/3 pi r squared times h. So 1/3 times pi times our radius. Our radius is 6. The whole thing across is 12. Our radius is 6 squared times our height. Our height is 8. Again, on my calculator, 6 times 6 is 36 times 8 times pi divided by 3. Then we get approximately 301.6. Okay, cubic units. Okay, so don't forget the Pythagorean theorem. All right, Isabel constructed a cylindrical vase that has a volume of 63 cubic centimeters. Jason constructed a cone that has the same height and the same radius. Do I need to go through all the work? Okay. Remember, all the way back here, what did we say? Volume of a cone will always be 1/3 the volume of a cylinder with the same height and radius. Well, they have the same height and radius. The cylinder is 63. We can multiply that by 1/3 or divide by 3. And when you do that, 21. So a lot of these, it's knowing that relationship. We didn't even have to do a lot of math for that one. All right. A cone has a volume of 300 units. A cylinder has a volume of 100 units. Is it possible that they have the same height and radius? Why or why not? Well, we just said here that a cone is 1/3 of a cylinder. If the cylinder is 100, 1/3 of that is not 300. It's like 33-ish, right? So we're going to say no. we're going to say no, not in all caps because I'm not yelling at you. The volume of the cone would be 1/3 of the cylinder if they had the same height and radius. Figured that'd be easier for you to read than me trying to write. Okay. So again, these are backwards. The cone shouldn't be more than the cylinder. A cylinder is going to have a greater volume if they're the same height and radius. It doesn't have to be that way, but for them to have the same height and same radius, that does. All right, last one. A cone has a volume of 942 cubic inches and a height of 9 inches. What is the radius? All right, this is solving an equation. Here's our formula. Find out what you know. We know that the volume is 942. We know that the height is 9. Okay? So let's simplify each side. Okay? We can multiply in any order. So I can basically say, what's 1/3 of 9? Right? Well, 1/3 of 9 is 3. So I have 3 times pi times the radius squared. Now I can divide both sides by 3 times pi. Be careful when you do this. When you type in your calculator, okay, don't put 942 divided by 3 times pi, because it's not, if you look here, look at it divided by 3, then it multiplied the whole thing by pi. That's not what we wanted. So you have to be careful, okay? You have to go 942 divided by, then in parentheses, put 3 pi. Okay, because then what it does is it takes this pi here and times it by 3, and that's what it divides by. Okay, so we get about 300. That's still not right. Hold on. Let me put it on my calculator. But that's what you still need to do. If you could see this, I am typing right now 942 divided by 3 pi in my calculator. I think I forgot to put the 3 in. I did. Maybe put the times sign, huh? I should get 99.9, which is about 100. And then we take the square root of each side. There we go. Okay? And so the square root of 100 is about 10. So what is the radius? We're going to say it's approximately 10 inches. Whew, I know that was a lot, guys, but just use your knowledge of the relationships between cylinders and cones. Use your formula, and you'll be able to figure out these problems.